Okay, physics. So I want to talk to you a bit about what happens when you get curves on graphs. So far we've been looking just at things that pretty much have straight lines, right? So we look at displacement, which has straight lines. It kind of looks like this. We've looked at velocity graphs, which have straight lines, and we've looked at acceleration graphs, which just have straight lines. But yeah, welcome to Physics C. Well, welcome to Physics Generally. You're going to have things that don't have straight lines. So let me point out a few important things about this. So I'm going to look at first displacement graph. So displacement graph is going to look like this, and this is what we'll see all the time. So we're going to see something which does not have straight lines on it anywhere. So a couple of things. I can find still the same thing. So I can find the average velocity, I can find the instantaneous velocity, I can figure out acceleration and all of that, and I can make predictions about the signs of things just by looking at this graph. So let's figure this out. So first thing I want to find is instantaneous velocity. So remember, I'm going to look at this graph, I'm going to look at the two things. The area under the curve tells me nothing. What the slope tells me on a displacement time graph, slope tells me velocity. I can find velocity at any point. Say I want to find velocity here by taking the tangent. So I'm going to put my pencil there, I'm going to put my ruler, I'm going to make a line that only touches, use a different color, make a line that only touches it at one point. So that is my tangent line. And now I have a straight line, I can find the slope from that. So the slope from my tangent line is going to tell me the velocity at that point in time. All right, so this is my instantaneous velocity. All right, I can do that here as well. I'm going to find my velocity here. Ooh, look at this. I can find my instantaneous velocity here, which is going to be pretty much a flat line. Imagine that touches it only in one place, and that's a tangent line. So now I'm going to have a velocity of 0. So notice what's happening, right? You can make predictions, right? So what's happening? I have a positive velocity going to 0. Right? Already you know something about acceleration, right? My change in velocity is going from positive to 0. Must be negative velocity, negative acceleration, right? So my velocity is negative going along here. Okay? Sorry, my acceleration is negative as I go across this part of the curve. Okay, so instantaneous, I can get instantaneous, in this case, velocity by taking the slope of the tangent line. I can find the average. Well, I'm going to find the average. I can use this graphically. A clean way to find average velocity, right, is here's where I started. Right, this is my displacement. So this tells me where I started. This is where I ended. So my average velocity is going to be, well, my displacement divided by time, right, or the slope of this line. So if I want to find the average velocity between 2 points, I can find the slope of the line on the displacement graph between those 2 time points. Okay, so notice there are a couple of important things here. So I mentioned already, so if I see a shape that's like this, I can make a prediction that my velocity is starting negative. Or sorry, my velocity is starting positive and going to 0, so my acceleration is going to be negative. Notice the reverse is happening here. So here I'm starting with my velocity, which is going to be 0 at this point. And as I go over here, my velocity, or my tangent line, now is going to be positive. Right? So in general, on a displacement graph, anything that's a part of a smile, right? So like this means my velocity is increasing, so my acceleration is going to be positive. Anything on my graph that's part of a frown, right? Just displacement graph, anything on displacement graph that's part of a frown, my acceleration is going to be negative. I don't know about the magnitude. I've got to do math and calculate it, but I can tell roughly what's going to happen. So it's really handy to check yourself, because sometimes you'll do math, make a mistake in the math. It's really easy to make an algebra mistake, especially in this class, because there's a lot of algebra. Really easy to make an algebra mistake, but you can check at the end to see, does it make sense? So if you calculate something that has, a negative acceleration and your graph is telling you from the eyeball that it should be positive, it's something to look at. Okay, we do the same thing for velocity as well. Okay, when I want to look at these graphs, I'm going to do the same 2 things. So I'm thinking about area under the curve and then the slope. And because it's a curve, instead of finding a slope between 2 points, I'm probably going to use a tangent line to get me the instantaneous value. So remember, area under the curve for the velocity graph, it's going to tell me displacement. It's a little trickier. I'm going to have to use calculus because it's not a straight line, so we'll get to that later. And then my slope on this, so on the slope, the rate of change of velocity, that's acceleration. So I can look at any point here, say I'm interested in this point, and I can make a tangent line, and the slope of that tangent line is going to tell me the acceleration at that point in time. I can do another one here, so I can see my acceleration at this point starts out positive and goes to 0. So my acceleration is going to be decreasing. So it is not constant acceleration. I'm not going to have a flat line for acceleration as we often have, but I'm going to have some sort of sloped line for acceleration. So we can draw this. So let's think about what acceleration graph is going to look like. So here we can make an acceleration graph. So let's see. So I'm going to have something that looks like this. This is going to be time. This is going to be acceleration. And meters per second squared, and I'm going to take a point, right? So if I figured, let me go back a little bit. So if I know this is going to be 0, well, at this point I know my acceleration is going to be 0. I know this point I have a positive acceleration, so I don't know what it is, but it's going to be up here someplace, so we'll call it positive. Think about this point, when I have 0 velocity, what's my acceleration? Well, be careful, my acceleration is my tangent line, so my acceleration is going to be negative, so at this point it's going to be negative. Then what happens here, right? I have negative acceleration going to 0, so my acceleration now is going to return to 0 at this point. Right? So my acceleration is increasing, right? So my rate of change of acceleration is going to be positive, but overall acceleration is going to be increasing. So then I'm going to end up with something positive over here. So the key for connecting these, so in this class, if you're given a velocity graph and you're not told anything else, you just have to assume constant acceleration. So if it's constant acceleration, that means that I'm not going to worry about the rate of change too much. But for the most part, I can just connect these. Right? So it looks like a straight line. So it looks like now I have acceleration is doing something like this, and then doing something like that. There will be times where we'll have non-constant acceleration. This is an example of that. And whenever you see a curve on a velocity graph, it's going to be non-constant acceleration. When you see a curve on a displacement graph, that just means you have acceleration. You can't tell necessarily if it's going to be a constant acceleration or non-constant acceleration. And we'll have functions, right? So we're going to end up having curves on acceleration graphs as well. So we'll have non-constant jerks. Anyway, it describes some people I know. Anyway, so these are things to worry about. So you want to be able to find instantaneous by using a tangent line. You want to find average, right? So I can find the average acceleration by looking at, graphically. I can find the average acceleration by going between 2 points I'm interested in. But be careful. So instantaneous tangent line, even on a curve, and average is going to be different. Anyway, hope that's helpful. Bye.